Dear colleagues, I would like to present a result of our research extraction of structural elements of the text using pragmatic features for the nomenclature of cases verification for the first International Symposium on Computer Science, Digital Economy and Intelligent Systems. This paper was prepared by Myroslav Havryliuk, Iryna Dumyn and Olena Vovk. Let me introduce myself. I am Myroslav Havryliuk, PhD student at the Department of Artificial Intelligence of Lviv Polytechnic National University, Ukraine. I obtained my bachelor degree in computer science in 2020 and my master's degree in computer science in 2021. Currently, I am working at the High-Speed Computational Intelligence Lab. The lab head is Professor Roman Tkachenko. Our lab is focusing on developing new neural and neural fuzzy structures for high-speed processing large volume of data. So let me talk about our research. The nomenclature of cases is a systematized list defining the retention periods for case files created during the institution's or organization's activity. Each institution compiles its nomenclature of cases and sends it to the State Archival Service of Ukraine for verification. The task of the archive employees is to check the retention periods in the nomenclature using regulatory documents. Currently, the verification process is manual. Obviously, this is very inefficient as human labor and time consumption are high. The task is highly specialized, so there is no software available to solve it. Therefore, the automation of verifying the nomenclature of cases is an unresolved and actual problem. An important aspect that must be taken into account is that there is no strict form of writing the text that must be checked. Thus, finding a way to extract content parts of the text for correct interpretation during verification isn't necessary. This paper aims to develop an automation method for the verification process of the nomenclature of cases and implement an information system based on it to reduce the time consumption of employees of the State Archival Service of Ukraine. The main contribution of this paper can be summarized as follows. We found a set of pragmatic features to automate the verification process of the nomenclature of cases by the State Archival Service of Ukraine for the first time. Also, we have developed an information system that implements our method for the first time. And we have obtained data on the effectiveness of this approach for the first time. We received 10 nomenclatures of cases from various organizations for our work. You can see example of data in the nomenclature of cases on this slide. Values that need to be checked are in the second column from the right. We have processed about 250 strings of characters, the values to be checked. The string indicates the retention period and a link to an articles from a regulatory documents. Regulatory documents for verification generally have a reasonably similar tabular structure. You can see example of data in a regulatory document, a list of standard documents on this slide. The attribute structure includes the article number, column 1, types of documents, column 2, Retention periods depending on the type of organization, columns 3 and 4, and remarks, column 5. Structured text T is data for which specific rules and presentation formats are defined. Usually, they are organized in a special predetermined way, simplifying the possibility of analyzing and extracting parts of the data. Accordingly, such a text can be divided by some set of k features or attributes ka. The result of division is an ordered set of text blocks tb. A set of text blocks tb, organized and ordered by a set of k attributes ka, where n is a sequence number of the text block, can be considered a text template tt. In turn, the text block tb consists of some set of structural elements se. The structural elements of a text block can be a character, a word, or a sentence. Given the heterogeneity of structural elements, some may be more important for further analysis and some less. A structure element can be presented as an ordered pair value rank, where rank is the importance of the structural element in the text block. An approach using the so-called pragmatic features is applied to determine the rank of the structural element, based on which further processing of the nomenclature of cases will be carried out. Pragmatic feature PR is a concept of k features of the text, according to which the structure of the text document is built. It can be presented as an ordered pair named priority, where name is the name of the pragmatic feature and priority is the importance of the pragmatic feature for further text analysis. Priority is equal to 0 or 1. Since the structure of the text being checked is always stable, a regular expression can be used to extract pragmatic features from the text. A regular expression regex is a sequence of characters that specifies a specific pattern to search for. In addition to regular characters, it can also contain meta characters with special meaning. In view of the above, the task is reduced to finding a set of pragmatic features, each of which in turn can be represented by a regular expression. Taking into account the specifics of the analyzed nomenclature, as well as the proposed approach to the design of the text template, we can formally divide the string being checked into parts. Based on the analysis of the values of the lines to be checked, a set of regular expressions was found to form pragmatic features and extract structural elements necessary for the algorithm's operation. Taking into account that each pragmatic feature is important for the further selection of structural units, the value of priority for each feature should be defined as 1. The retention period and reference to the remark are always at the beginning of the string before the sequence of characters st. Case may be upper 2. Therefore, the corresponding regular expression regex and pragmatic feature PR1 you can see on this slide. The remaining string is a reference to an article or several articles of the regulatory document. This reminder can be divided into fragments starting with the sequence of characters st and possibly ending with the abbreviation of the regulatory document. So, corresponding pragmatic feature you can see on this slide. After that, it is necessary to extract the abbreviation of the normative document of each of such found fragments. It can be done using the expressions on the slide. In addition, in each fragment, we need to extract the article number to which the author refers. It can be done using regex form. Using the appropriate abbreviations, we can query the database and compare the author's values of the retention period with those specified in the regulatory documents. When comparing retention periods, we need to discard the ending that is responsible for referring to remarks using corresponding regular expression regex 5 and pragmatic feature PR5. So, as a result, a set of pragmatic features can be presented in the form of the set of regular expressions. The verification scheme can be presented in the form of a decision tree that you can see on this slide. We conducted an analysis and decided to divide remarks in regulatory documents into two classes, A and B. The conceptual difference between these classes is that a base retention period with a B class remark can be unambiguously compared to the value in the case nomenclature, while a base retention period with an A class remark cannot, because A class remark specifies a different retention period from the base one. The task of the system is to paint each case in a particular color. Green, the retention period is correct. Red, when the retention period is incorrect. Yellow means that the retention period cannot be checked because the case is controlled by regulatory documents that are not in the database. White means the retention period cannot be verified by our system due to the presence of references to articles with an A-class remarks. We used 5 nomenclatures of cases to test our system. You can see on the slide testing results. As can be seen from the table, the largest number of cases is colored green. In each of the checked nomenclature of cases, the system selected about half as correct. In general, the percentage of green cases in this sample is about 54. Yellow cases make up about 9% of the total number. In most nomenclatures of cases, this value is even smaller, but in some it is much larger. The percentage of red cases in this example is approximately 19. However, a significant percentage fluctuation are noticeable depending on the tested nomenclature of cases. For white cases, the percentage is about 18. It is relatively large, but it is much smaller in some nomenclatures of cases. Employees of the State Archival Service of Ukraine use the system during their work. They confirmed that it works correctly. Employees have to correct all incorrectly specified retention periods, so they do not benefit from using the system in this case. The same applies to yellow, because the archive agrees the retention periods with the authors, and white um, when a process is no different from manual verification. The information given above allows for assessing the effectiveness of the information system. It can be assumed that the time for checking each case is approximately the same. The concept of checking with the program is that the green lines are not taken into account by the expert, which helps to save time. Then the application of the system can save time by about 15%, which means that the duration of the process is reduced by half. In conclusion, I would say that the automation of verifying in the nomenclature of cases is an unresolved and actual problem. An important aspect that must be taken into account is that there is no strict form of writing the text that must be checked. Finding a way to extract content parts of the text for correct interpretation during verification is necessary. This study focuses on developing an automation method for the verification process of the nomenclature of cases and implementing an information system based on it to reduce the time consumption of employees of the State Archival Service of Ukraine. The authors have found a set of pragmatic features to automate the verification process of the nomenclature of cases by the State Archival Service of Ukraine. We have developed an information system that implements our method. Also, we have obtained data on the effectiveness of this approach. Testing results demonstrated the effectiveness of using our system. It reduces time spent on verification by about 50%. The State Archival Service of Ukraine successfully uses this system. Further research will be carried out to find a way of checking the retention period of cases, which is colored white in the current version of the system. Thank you for your attention.